Hello, fellow explorers of the digital frontier. Ernis here, ready to unravel another mind-bending academic paper for you. Today, we're diving deep into the world of reinforcement learning from human feedback, or RLHF, with a paper titled, Greedy Sampling is Provably Efficient for RLHF. Now, before your eyes glaze over, let me tell you why this is so exciting. Have you ever wondered how those large language models, those chatbots and AI assistants, learn to be so, well, helpful? A big part of that is RLHF, where humans give feedback to guide the AI. And this paper? It's about making that process way more efficient. Now, imagine a grand library, not unlike the Library of Alexandria, but filled with algorithms instead of scrolls. In this library, we're looking for the most efficient path to guide our AI. The authors of this paper, Wu, Shi, Yang, and Shen, are essentially arguing that sometimes, the greediest path is actually the fastest. I know, greedy doesn't sound very scientific, does it? But in this context, it's about directly using the best available data at each step, rather than trying to be too clever with complex estimations. Let's construct our memory palace to help us navigate this paper. Picture a vibrant, neon-lit city, where each district represents a key concept. Our first stop is the introduction district, the bustling heart of our city. Here, the authors lay down the basics of RLHF. They explain how it differs from traditional reinforcement learning. In RLHF, instead of getting absolute scores, the AI gets preferences. It's like saying, I like answer A more than answer B, rather than giving A 7/10 and B A 5/10. Makes sense, right? It's easier for us humans too. Also, RLHF incorporates something called KL regularization, a penalty that keeps the AI from straying too far from its original behavior. Why? Well, you don't want your helpful chatbot suddenly deciding to write sonnets about existential angst, do you? On to the next district, Problem Formulation Plaza. In this part of town, the authors get down to brass tacks with the general preference model and the Bradley-Terry model. The general preference model is like a flexible framework for capturing human preferences. It has attracted increasing attention recently, due to its empirical flexibility and adaptability. The Bradley-Terry model, on the other hand, is a special case of the general preference model, a statistical model that predicts the outcome of comparisons. It's like a simplified version of the general preference model. Let's move to the properties of the optimal policy class park. Here, the paper highlights some crucial properties of the best possible policies under this KL regularized framework. The optimal policies need to be stochastic and have bounded ratios. This is a key piece of the puzzle. Now, things get really interesting with the algorithm design arena. Here, the authors introduce their greedy sampling algorithm. Instead of constructing elaborate confidence intervals or trying to predict the future, they simply choose the action that looks best right now. Based on the available data, it's like choosing the shiniest apple at the market, simple, direct, and surprisingly effective. Next stop on our tour is Theoretical Analysis Terrace, where the authors unleash the math. Don't worry, I'll spare you the equations, but the gist is this. They prove that their greedy sampling algorithm achieves a logarithmic regret in the online setting. The implications of this are huge. To the best of our knowledge, this is the first analysis of RLHF under the general preference model that can achieve an O log T regret bound. Previous attempts at greedy sampling in RLHF required more sophisticated techniques for comparable regret, and it matches the upper bounds under optimism and pessimism. The findings are corroborated by those at the Experiment Emporium, where they put their algorithm to the test. The results? The simple greedy sampling approach achieves statistically comparable performance to prior methods. Let's jump to the discussions district. From a theoretical perspective, The authors suggest that the bounds of greedy sampling can be further tightened by reducing multiplicative constants. Empirically, greedy sampling seems to be more effective than prior methods and can be tested via large-scale experiments. Lastly, this work can be extended to multi-step RL, as the current work focuses on the single-step setting. The last stop on our tour is the Related Works Road. The authors compare their work to the studies of Bandit and RLHF with the BT model, and RLHF with the general preference model. As we're wrapping up our tour of the Memory Palace, it's time to appreciate the key insight from this paper. The authors show that the KL regularization confines every candidate optimal policy within a bounded likelihood ratio regime around the reference policy. In other words, it constrains the scope of the exploration, making greedy sampling a viable strategy. So, what does all this mean for you? Well, if you're working on training AI assistants, this paper offers a powerful new tool in your arsenal. Greedy sampling could lead to faster, more efficient training without sacrificing performance. And if you're simply curious about the future of AI, this paper offers a fascinating glimpse into the cutting-edge research that's shaping that future. Of course, there's still plenty of work to be done. The authors themselves point out several avenues for future research, including tightening the theoretical bounds and exploring the algorithm's performance in more complex scenarios. But for now, let's celebrate this important step forward in our understanding of RLHF. I hope this journey through the greedy sampling is provably efficient for RLHF. Paper has sparked your curiosity and given you a taste of the exciting world of AI research. Until next time, keep exploring, keep questioning, and keep pushing the boundaries of what's possible. This is Ernis, signing off from PaperLedge.